Okay, welcome to my final project. This is Cody Oakes for CIT260. Eric Puma and I have been working all semester on Fire on the Horizon, and I'm going to go over a little bit of what we did towards the end of the second half of the semester, as well as the end result for our game. And so first off, I'm going to talk a little bit about static class variables and non-static instance variables. To start out, non-static variables. Non-static variables cannot be defined, and they cannot have a code block after the function signature of an interface class. So you can see here, this is an example of a non-static variable. This shape has these variables, get area, get perimeter, get volume. None of them have been defined, and there is no code block after the function function signature. So to call these functions, these non-static instances, you can do that by using the implements keyword. Just like so. So we have circle that implements shape that we've created up here. And then it can use these variables that we haven't defined. So after you get to the function with the unique block of code, this @override is required so that you can change that from the initial shape instance that you've associated that with. Next, we're going to talk about the static class variables. Static variables are final. So the value has to be assigned to the variable when it's defined, and it has to have a block of code. But inside that block of code, you can't modify the value of the static variable after it's already been defined in the class. So you can see here we have the public static, and that color, the line color, is black. And then we do have our block of code, but you can see there the line color doesn't, that it doesn't change the value of that. It just calls it and returns it. So you can call those static variables by qualifying them in the variable or function with the interface class name. So you can see here we have, once again, circle that implements shape. And inside of that, we're going to qualify the variable with the function name. So the public void draw, we're going to go ahead and pull that up, and then shape get line color to reference that value. Next, we're going to talk about arrays, array lists, and enums. So if we go first off with an array, it's used to model a fixed length of objects or primitive values. So integers, floats, booleans, and characters. And they can be changed during execution. All of the objects in the list have to be of the same data type, however. So when would we use an array? The answer is we would use an array when we have, when the list is of fixed length. The list items may dynamically change, so the values inside that list are going to change possibly, and the items all have the same data type. Next, we're going to talk a little bit about an array list. So array lists are variable length lists, so they can have a different number of length to that list. They can also contain different types of objects. So objects of any type can be dynamically added and or removed from the list at any time. So that's when we would use an array list, is when we need to add or remove objects from the list throughout the program, and or if the objects are of a different data type. The last one is a little bit different still. This enum list is a special type of list. It has a fixed length where all the objects in the list are the same type. And unlike an array, the objects or values in the list are constant and will never be changed. So, I mean, it's kind of a special case use, but we would use it on an occasion when the number of items is fixed in our list, the items are constant and aren't going to change, and all the items are of the same data type. Lastly, for this section, for the array section, we're going to talk a little bit about how you're going to access each of those elements inside of your array, and a little bit of the syntax for that. So the easiest way to access those items is a basic for loop. So you can see here the for statement initializes with inside this loop. We set it to 0, and then the loop is run for the length of the array. So it looks at how many items are inside of our array, and as long as I is less than that, it's going to continue to run. And then we put an increment value at the end, so that as we run through each time, it's going to get a little bit higher. So the really cool thing is that we can actually index our array with that I value as well. So as our loop goes up a value, so does the index in that array. And that's how we're going to go through each item within that array. And so that's how we can then, as we go through that, we can use it different ways and be able to reference that indexed item list. So next we're going to talk a little bit about throw, propagate, and catch for the custom airtime errors or runtime errors in our code. And so this is a little bit about how it's done. Sorry, I didn't realize that picture was so small. But basically, exception handling in Java is similar to throwing and catching a ball. And I really like this analogy with inside the reading. It says that in Java, when a runtime error is detected, an object representing that error is created and thrown. The object thrown should be caught and handled in a meaningful way. So Java's created this try-catch statement that was added to handle these runtime errors and be able to catch them. And so basically what happens here, we can see we have this try where it's going to try this batch of code, and then if it catches an error, it's gonna do something with that. And what this particular one is gonna do is it's gonna print out an error message so that we can understand what the error is and what's happening, so that we can fix it, or so that our end users can understand what they've done wrong. And then propagating, I thought that was really neat as we read about it in the reading a couple weeks ago. So what happens whenever what you can do is, if there isn't a try catch statement within that hierarchy, within the level of hierarchy that you're at that time, you can actually propagate that error so that it continues to move up the hierarchy ladder until it does run into a try catch statement, and then those errors can still be handled, and we can still get a meaningful statement out of them as well. So that's a little bit about throw, propagate, and catch for those custom runtime errors. Next, we're going to talk a little bit about character stream classes versus byte stream classes. A little bit about how they're different and why we would use them. So first off, a byte stream, what it's going to do is, well, what I thought was interesting from the reading is that initially, whenever Java launched, it only supported IO file streams that were byte streams. And byte streams are a little different because they read and write in binary only. And so they read and write a single byte at a time. And the problem with that is that whenever we get to actual character values, we can't see those in bytes. So character values are encoded with this ASCII or Unicode formats. and they're mapped to bytes so that we can understand what the characters actually are, what the binary values are in characters, and so that we can understand so that it actually translates into a language. And so byte streams, we aren't going to use those for any character stream or character values, but we will use it anytime that we want to do an input or an output in binary. Character streams are what Java added later so that we could solve that problem, and so that we can basically, character streams are able to handle the reading and writing of any character data regardless of the format that it's stored in. And this is the stream that Java recommends for reading and writing of all character data. So here's one example of how you would use a character stream. You can see here inside of our function, system out and system in. We use that a lot in our program. And system out and system in is a character stream that allows us to read and write to the console. And so you can see here, system out print line, enter a description of the item purchased, and in our console portion here, it'll print that out. With a system out, it's able to write to the console, and then with a system in, you can see that we've set that as a variable here, initialized it, and then we reuse it throughout this function, and that allows us to read what a user's inputting to the console, so that we can use that later. So that's a little bit about character streams and how we can use them. Lastly, I'd like to demonstrate a little bit of our program. I'm not going to go through the whole thing, but both Eric and I were really satisfied with what we were able to accomplish. It didn't quite end up having all of the features that we wanted to include, but it did have a lot of the features, and it did meet the requirements for the game, and so we were really pleased with this semester. We were pleased with what we learned and what we were able to do with what we learned. So I'll just do a little bit of a demonstration here before we wrap it up. So this is Fire in the Horizon. And basically the premise of the game is that you and your comrades are trying to cross this battlefield without dying. And so we have this opener menu that displays a little bit of the background of the game and asks for the user to input their name. It gives a little bit of a welcome screen, and then we enter into the main menu. You can see we can start a new game from here. We can start an existing game. We can learn a little bit more about how to play. We can save or we can exit. And so we're going to go ahead and start a new game at this time. That takes us to the game menu. Inside the game menu, we're able to view our food inventory as a second item on the list, and you can see that we have a small inventory of food and the stock values of that inventory. We also have character traits, which gives a little bit of the background to the people who are traveling with you. We got Tom, Luigi, and Anna, and it gives a little bit of background about each of those characters, which is kind of fun for the user to go through. Lastly, we have the View Battlefield and Move Forward menu item, and what that'll do is whenever that's selected, it gives a little bit about where you're at on the map or where you're at in the battlefield and what's going on, and then it'll actually display the map and show where you're at so you can get to the end of the game. And it also initiates a search for food. And so you can see that sometimes we'll be able to find food as we cross this battlefield, and other times we're going to lose food. And if at any time we lose and we get down to 0 food items, then our company starves and we lose the game. We've actually gone through in the code and set that to a randomizer, so those values are different every time you move through the map. The scenes are the same, so you'll either gather food or lose food at each time during that particular scene, but the amount that you gather will be different every time. So in addition to the gathering and losing of food, you can see we ate a tomato here, and we were able to find food at this section. You can see if we go back to our food inventory that we have a, a plethora of food items here now in stock. And sometimes those will go down because the randomizer will pop out values that are really small, and we'll continue to lose food as we cross the battlefield. We have died that way, but we've changed it so that the odds are a little bit more in the user's favor for that particular aspect of the game. In addition to that, we also have challenge scenes. So in this particular scene, we can see that there's a riddling soldier who's going to ask us questions, and we have to reply with the correct values. If we reply with incorrect values, the riddling soldier kills our company, and we have to restart the game. And so that's the basic premise of the game. Eric and I, we took a long time to develop a lot of the backstory, and we really enjoyed doing it. We learned a lot about Java and a lot about game creation, and it's been really fun. So as you can see here, if we get the answer right, then we're allowed to continue on, and we'll go to the next not battle scene, but the next trial scene. And if we get the answer wrong here, you can see, nice try. Here's a bullet as your reward. Game over, and we're brought back to the initial start of the game. I'm about out of time, but that's our game. We're really proud of it. We're really excited. Both of us really enjoyed this semester. We had a good time, and that's where we ended. So thanks for your time. I really appreciate it, and we'll talk to you all soon.